Okie dokie. Hello, if you are watching this because you were gone, or if you're watching this in class on Friday, here is your 3.7 quick write. This is the last quick write of the semester. It is what is one thing you have learned / accomplished / are proud of from this semester, because this is the last quick write of the entire semester, because this is the last set of notes for the semester. So go ahead and have Ms. Hanson, your sub, pause this video, and then once you guys are done with your quick write, we'll get back to notes. Okay. We are doing 3.7 today. If we don't already have 3.7 note sheets, get those distributed. It is second hour or whenever you're watching this. Okay, for the sixth and final time, a system of equations is a collection of two or more equations. So we are solving two equations at the same time. The solution to our system of equations is still going to be the point that makes both of our equations true. And I will show you guys on one of these at least that you can plug in x and y to check your solution in both of your original equations. Okay, today we are doing the exact same thing we did yesterday and Tuesday and Wednesday, whatever days. I don't know when you're watching this video. We are solving by elimination. The only thing that's different today is you might have to multiply both of your equations so that a variable will cancel out. So instead of just manipulating one equation, you might have to multiply both. Then, once you get it so that a variable will cancel out, you are going to add your equations together, eliminating a variable, solve for the remaining variable, and you'll plug that in, solve for the other one. Steps 4, 5, and 6 are the same for everything, substitution and elimination. It's just the beginning that's different. All right, first problem here. We've got 4x plus 5y equals negative 14, and 6x plus 3y equals 6. We need to make either our x's or our y's cancel out. We have choices here. There is literally an infinite number of ways that you can solve every single one of these problems and still get to the correct answer. We can either make our x's cancel out by making our x's be the same number, or we can make our y's cancel out. In order to find what we're going to turn them into, we are going to have to find what's called our lowest common multiple today. So your lowest common multiple is the smallest number that is a multiple of both numbers. So we're not looking at factors, we're looking at multiples. So the multiples of like 3 are like 3, 6, 9, 12. Okay? So let's look at 4 and 6. Think about the multiples of 4 are 4, 8, 12, 16, 20. The multiples of 6 are 6, 12, 18, 24. What is the smallest one that was on both of those lists? 12. So the lowest common multiple of 4 and 6 is 12. So I can make them a 12x and a negative 12x and cancel that. Just because we only have a couple examples, I want to talk about the other thing that we could do. Multiples of 5, if we wanted to make our y's cancel. Multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40. Okay. Multiples of 3 are 3, 6, 9, 12, 15. That would be the first one. So we could make our y's cancel by turning them into 15 and negative 15. Or we can make our x's cancel by turning them into 12 and negative 12. Both of those are completely good ways to do this. We are going to choose to do x's on this one just because I want to do y's on the next one. That's just me planning ahead. But you could do y's. So when you're working on your assignment, you can choose. The other thing that I want to say, it's easiest to do your lowest common multiple. You could do any common multiple. If I wanted to, I could turn these both into 24. So I can multiply my 4 by 6 and my 6 by 4 and make these 24x and negative 24x. If I wanted to, I could make both of these 96. I can multiply the top one by 24. I can multiply the bottom one by, what's 96 divided by 6? 10, 16. I can multiply the bottom one by 16. So I could do that if I wanted to. There's no real reason to make your numbers that unnecessarily large. But if you can't find the lowest common multiple, and it's a different common multiple, it'll still be correct, okay? So I know that was a lot before this first one. Let's go ahead and cancel our x's. We are making them be 12x and negative 12x. What do I need to multiply my top equation by to have 12x? 3. Okay. What do I need to multiply my bottom equation by to have negative 12x? Negative 2. Okay. So they have to be the same number, opposite signs. You could go either direction. What's up? Yeah, just grab one off the board and I'll replenish it later. Welcome. Hey, so they have to be the same number, opposite signs. We could do negative 3 on top and positive 2 on bottom if we wanted to. So again, infinite number of ways you could do this. But this is how we're going to do this one. So the top equation, 3 times 4x is going to be 12x. 3 times 5y is 15y. Oh, I almost forgot my y. 3 times 4, 3 times 5. And then 3 times negative 14 is negative 42. All right, the bottom equation, negative 2 times 6x is negative 12x. Negative 2 times 3y is negative 6y. And 6 times negative 2 is negative 12. So I now have 2 new and improved equations. Okay. Before we add those together and eliminate our x's, does anyone have any questions? Okay. My 2 pieces of advice to you. Make sure your x's look like x's and your y's look like y's. And make sure you keep things lined up so you can add together easily. Now we can add together easily. So 12x plus negative 12x cancels out, eliminates, that's the goal. 15y and negative 6y is 15 minus 6, which was 9y. Okay, and then negative 42 and negative 12 is negative 54. Okay, we can solve for y now. So we divide 9 by 9. Y equals negative 54 divided by 9, which is 6, right? Yeah, negative 6. Do you guys know the nines trick with your fingers?
Yeah.
Okay, I can't believe I've made it this far this semester without showing you guys this. This is perfect, because now I can just show it in the video. Okay, can I get all 10 of my fingers in there? Yeah. All right, so you have 10 fingers, right? 1 times 9, you put down your first finger because you're multiplying by 1. 1 times 9 is 9. 1 times 2, put down your second finger, is 18. So I have a 1 here and 8 here. 9 times 3, I put down my third finger, is 27. 9 times 4 is 36. 9 times 5 is 45. 9 times 6, so I'm putting down my sixth finger, is 54. 9 times 7 is 63. 9 times 8 is 72. 9 times 9 is 81. And 9 times 10 is 9. And then I have 0 over there, so 90. Okay? So, if you have 10 fingers, that works. My grandpa Steve only had 9 fingers, so that wouldn't work for him. It was a whole thing. It got shot off at a bank robbery in China. It was no big deal. Allegedly, I'm not sure. I like how I'm recording this in the video, and now everyone's going to hear that all day. Yeah. He was like working as a security guard at a bank, and it allegedly got shot off. Which, like, if you're going to get something shot off, like your fingers, like, better than, like, getting shot in, like, a real limb that you need, I guess. I don't know. But then he would point at everything with his middle finger, so it looked like he was flipping everyone off. Okay. Any questions about solving for y?
Did they ever find the finger?
I don't know. This was like a really long time ago, halfway across the world. Okay, we are going to plug in -6 for y. We can plug it into either original equation. Yesterday, I was having you guys always plug it into the top equation. But in this one, I think that bottom equation looks easier because that -14 is just like another thing to deal with. So let's use the bottom equation today. So we've got, or for this one at least, 6x plus 3y equals 6. If you were working ahead of me and already plugged it into the top equation, you should get the same thing we're going to get. You don't need to redo it. Just double check you get the same thing we're going to get. We plug in -6 for y. So I'm going to have 6x plus 3 times -6 equals 6. Okay. 3 times -6 is -18. So now I've got 6x minus 18 equals 6. And then add 18 to both sides. 6x equals 24. And then I divide both sides by 6. I get x equals 4. How do we write our final answer? Ordered pair with x first, so 4, -6. Awesome. Wait. Just because I know you guys will ignore me and start gluing on the next one, let's check on this one just so I can remind you guys, and then it's in the video too, how to check a solution. So you plug in x and y. I'm going to cover up that. You plug in x and y, so 4 and -6 for x and y. Go back to your original equations. Because if you made a mistake in the first step, this would catch it, but only if you go all the way back to your originals. So 4x would be 4 times 4, plus 5y would be plus 5 times -6 is -14. That one checks out. And then the other one, 6x, so 6 times 4, plus 3y, so plus 3 times -6 is 6. So you can plug in x and y to check. So you should be able to turn in your test, and if you checked all of your equations, you can know that you have most of them, all of them right. Unless something insane happened. Okay, questions, concerns, emotions, thoughts? Okay, last example of the semester, y'all. 3x minus 2y equals 2. 5x plus 5y equals -30. What is the lowest common multiple of 3 and 5? 15. What is the lowest common multiple of 2 and 5? 10. Why is it going to be easier to do y's instead of x's in this one?
Because there are
Yeah. So we already on our y's have a -2 and a +5. So we can turn these into -10 and +10, and we don't have to multiply by a negative at all in this one. So let's cancel our y's. Plus also I want to do one where we cancel y's. So we're going to multiply our top equation by 5. We'll multiply our bottom equation by 2. Okay. 5 times 3 is 15x. 5 times -2 is -10y. And then 2 times 5 is 10. Okay. Bottom equation, 2 times 5x is 10x. 2 times 5y is 10y. And -30 times 2 is -60. Okay. Questions, concerns, emotions, thoughts about multiplying there. Okay. We are ready to do some elimination. Add those together. 15x and 10x are 25x. It's like you guys can add when it's by fives. Those are easy. Negative 10y plus 10y. What happens there? They cancel. They eliminate. And then 10 plus negative 60 or 10 minus 60 is negative 50. So I divide by 25. I get x equals negative 50 divided by 25 is negative 2. Right. You can use either original equation. When you're looking back at your original equations, you can either always pick the first one, always pick the second one, do it random. I, at this point, kind of like to pick one that like I think is going to be easier. So like these numbers are way smaller, so I'm going to do the top one. 3x minus 2y equals 2. I know that x equals negative 2, so I can plug that in. 3 times negative 2 minus 2y equals 2. 3 times negative 2 is negative 6 minus 2y equals 2. We're going to add 6 to both sides. Negative 2y equals 8. And then we finish out by dividing both sides by negative 2. And we get y equals negative 4. Very negative problem. Okay, and then I'm sitting right here, because this is the first time I've done this today, checking into my head. 5 times negative 2, 5 times negative 4, yeah. So you can also just like, if you don't want to do it in your calculator, you can sit here and do this. Okay, what's 5 times negative 2? What's 5 times negative 4? Add those together. Write your answer as an ordered pair, negative 2, negative 4. Okay, one reminder, because there wasn't any on this. If your variables all cancel out, then you are left with a true statement. How many solutions do you have? Variables cancel out, true statement. Infinite solutions. Variables cancel out, false statement. No solutions. How many solutions did we have on this problem? 1. So these are our one solution problems. When you actually solve it out, that's a one solution. So it's either one solution, or it's all of the solutions, which is infinite, or none of the solutions. Okay? Those are the 3 options. Go ahead and get these glued in. I'm going to stop this video. Bye, video. Nice knowing you.